Okay, so this is Unit 2. This is video number 4. And we are looking at the top of page 5. So example, a ball is thrown downward from a 140 meter high building with an initial downward velocity of 15 meters per second. So before we go any further, let's take a look at what we have as far as the information goes. It says the ball is thrown downward. Now remember, when we dropped the ball, its initial velocity was 0. But if we are throwing the ball downward, that means that our velocity is not 0 initially. It already has some velocity by the time that it leaves your hand. The initial velocity is provided in the question. It is 15 meters per second down. When we're talking about things falling, we say that this is negative 15 meters per second. This negative is implying the direction, which is down. In general, with free fall, positive velocity is up, negative velocity is down. Just like our acceleration of gravity, g, it was negative 9.8 meters per second squared, or negative 10 meters per second squared, and the 10 imply the downward direction. Find its velocity after 2 seconds. So we are relating velocity and time. This is a t. Find its velocity, that's vf. Our formula that relates velocity and time, final velocity equals initial velocity, plus the acceleration times the time. So we plug in our numbers here. Initial velocity is negative 15 meters per second, plus the acceleration of gravity, a, negative 10 meters per second squared, and our time is 2 seconds. And so we end up with negative 15 meters per second plus negative 20 meters per second. It's downward velocity after 2 seconds. Negative 35 meters per second. Again, the negative represents down. How far has it fallen after 2 seconds? How far? We're talking about distance. 2 seconds is time. Remember, there were 2 ways of figuring this out. The first one is your actual physics formula that relates distance and time. Distance equals initial velocity times the time plus 1/2 acceleration times the square of the time. So we plug in our numbers. Initial velocity, negative 15 meters per second. Time is 2 seconds. Plus 1/2. Acceleration is negative 10. And the time is 2 seconds, which needs to be squared. The most common student mistake is forgetting to square the time. So here's negative 30 meters plus 4 to negative 20, and this is meters because second squared will cancel. Distance equals negative 50 meters, and you could say it has fallen 50 meters. Method 2 works just like it did in example 1. This is your distance equals the average rate times the time. So distance equals the average rate here. And so let's write this off to the side. Let's move down. Average rate equals our initial velocity plus our final velocity. This is after 2 seconds. So was example 2a. This is its speed after 2 seconds. And we divide that by 2 because free fall is uniform acceleration. So the average velocity over this interval, negative 25 meters per second. So we plug that number back in, negative 25 meters per second, and the time is 2 seconds. Seconds will cancel, and your distance is negative 50 meters. So you're going to get the same answer both using both methods. Just depends on your preference as far as which one you want to use. So if we were going to represent this, here's time in seconds. Here's velocity in meters per second. And here's a picture. Here is the object, the ball, with an initial downward velocity at time 0. Velocity is negative 15 meters per second. After 1 second, it might be here. Its velocity is now 10 meters per second down greater. After 2 seconds, it might be here, negative 35, 3, negative 45, 4, negative 55, and so on as it falls. Its velocity is increasing in the downward direction by 10 every second. This is a familiar question, part C. How far does it fall in the 3rd second? So let's take a look at this again like we did last time. So here's time versus velocity. If you just drew this picture, you don't really need to draw it a second time. If you haven't drawn it all, you might go ahead and do it. At time 0, negative 15, time 1, second, negative 25, 2, negative 35, 3, negative 45, and so on. Number 4. So this says how far does it fall in the 3rd second? So remember in a previous video, we talked about this. So from 0 to 1, this is the 1st second. From 1 second to 2 seconds, this is the 2nd second. And the 3rd second would be between 2 and 3. And this is the interval that we are concerned with, the 3rd second. Method number 1, we're talking about how far does it fall, distance. And in the 3rd second, this is going to be a time interval of 1 second. From here to here, 1 second. So the formula that relates distance and time. We're going to go ahead, fill in our numbers here. The initial velocity for the 3rd second, not from previous examples, initial velocity from the 3rd second. Remember, we're just looking at this interval here. the initial velocity is negative 35 meters per second. The time interval is 1 second plus 1/2. Acceleration of gravity is negative 10 meters per second squared. And the time squared is 1 second squared. So here we have negative 35 meters plus negative, so we've got negative 5, and here it is. And so the total distance here is negative 40 meters. You could just say it falls 40 meters. Method number 2, again, distance equals R average divided by T. So distance equals, remember R average is the sum of the two velocities divided by 2 because it is uniform acceleration. And the time interval here is 1 second. And so here we have 80 divided by 2, negative 40, and the seconds will cancel, negative 40 meters. Yeah, this was meters per second. How long does it take to reach the ground? How long, that's time, and to reach the ground, we're talking about really the height of the building. So the distance equals 140 meters. So our formula that relates distance and time and plugging in some numbers. Now, we are talking about from the time it is thrown up here till the time it hits the ground. So we are looking at an initial velocity of negative 15 again. So the distance, the height of the building is 140 meters, but the ball is going to fall 140 meters. Remember, in physics, in free fall problems, positive is up, negative is down. So even though the height of the building is 140 meters, it's going to fall 140 meters, which is negative. Equals the initial velocity is negative 15 meters per second. Here's T for the time, plus 1/2. A is negative 10 meters per second squared, and we're looking for T squared. So by the time that we look at this, we have a T, we have a T squared. We're going to need everything on the same side, and we're going to end up with, we're going to add 140 over here. 0 equals, so we've got, this is going to be negative 5t squared minus 15t. And I'm taking the units out just to make this a little cleaner. Plus 140. And so you could use the quadratic formula if you wanted to, but it's going to be easier just to factor this one out. You could take a negative 5 out of everything. Everything here is divisible by 5. So we have 0 equals, negative 5. 0 equals t squared plus 3t minus 28. you're going to have t times t is t squared, and you're going to have something equaling 28. So you could try -7 and +4, but that would work here, not this one. So let's try again. Well, +7 and -4, that would be -28 multiplied, added together would be +3t. And so we're good here. So when you're looking at these, you're going to get two answers. Time equals -7 seconds, and time equals 4 seconds. In physics, this answer doesn't make sense. A negative time, when we're talking about falling, just doesn't make sense. And so the positive answer, time equals 4 seconds, is the one that makes sense. How fast is it going after falling halfway? So how fast, we're talking about final velocity. Halfway, we're talking about not half of the time, we're talking about half of the distance. So relating velocity and distance comes with this formula: vf squared equals vi squared plus twice the acceleration times the distance. So let's plug in some numbers. Vf squared equals, the initial velocity is -15 meters per second. We are throwing it down, it's the same example here. We need to square this velocity. Plus 2 times the acceleration of gravity is -10 meters per second squared, times the distance. Distance was originally 140, half of that is 70, and we're talking about falling, so it's -70 meters. So final velocity squared, we have 225 meters squared per second squared plus 1,400 meters squared per second squared. Take the square root of everything, and that will give us final velocity equals, and the square root of 1,625, 40.31, and that's meters per second. And so at this point, it is going 40.31 meters per second. So if I were going to look back at this little diagram that we drew, the halfway point is probably somewhere in right here. How fast is it going as it hits the ground? How fast? That's final velocity. As it hits the ground, that information tells us that it fell the entire 140 meters from the top of the building. Distance equals 140 meters for the building, -140 meters as it fell. Formula to relate velocity and distance, same one that we just used. Final velocity squared equals initial velocity squared plus twice the acceleration times the distance. Initial velocity is still -15 meters per second. Don't forget to square it. Plus 2. Acceleration of gravity is -10, and the distance is -140 meters. So VF squared equals, again, this is 225 meters squared per second squared, plus this time we have 2,800 meters squared per second squared. And final velocity squared is 3,025. Square root of that tells us that as it hits the ground, it is traveling 55 meters per second down. Or you could say negative 55 meters per second. The reason I put down here is because the way the formulas work out, it gave us a positive answer, and we just had to remember the direction it was falling. And so negative would work or down would work.